Okay, everybody. I don't know why you're here, but where? My name is David Zhang. I'll be kind of like the teacher. Yeah, that's kind of the idea. Today's gonna be like very basic, like extremely basic. I kind of like. So kind of like the idea of this class is that I believe that, especially with like a lot of school classes, they kind of rush into things because of AP exams, a lot of like, I guess, deadlines. And what ends up happening is that you'll see in like later CS classes where people are asking so many questions, they're getting so behind, and like they're really struggling with CS. Okay, and I don't want that to happen to any of you. I need a marker. I think this was the marker. Stop recording me, dude. Anyways. I hope you all enjoy. I'm kind of a very outgoing guy. But yeah, so today will be like the very basic of the basic. I guess we'll probably, next time on this Thursday, I'll implement more advanced topics to get like the other people interested. But for today, we're going to be doing very basic stuff. So I have notes. I sent them on Discord. If you want to look at them, they'll be pretty useful. Just maybe glance at them at your phone, with your phone once or twice. But basically, let's see. Okay, I'll do kind of a warm-up question. What do y'all think programming is? You?
A language that the computer understands.
Okay, yeah, a language, some sort of tool to interpret between machine learning, or machines and like people. Yeah.
Write codes to solve problems.
Yeah, solve problems. That's a good way too. I like the solve problems way too. I'll write this. Programming. If my handwriting sucks, I'm sorry.
It's actually decent.
Solve problems. Did someone say it was decent? Okay, solve problems. That's kind of what we're going to be doing in school. Like I said earlier, if you went to the first meeting, basically we're going to be solving a set of problems in some kind of a competition setting. My shoelace is every time. Okay, I'm gonna take this off because I want to see. Okay. So in like the very, very bottom up, programming is kind of like this. You have an input, you have code, and you have an output. Okay. So what do y'all think input is? You.
User answer.
What do you got?
User answer.
What?
Like the user answered it.
Okay, yeah. What do you think?
Like different applications.
I couldn't hear you say it once.
Like the different things you need so you can code.
I guess, yeah. Okay. So in a sense, input can include like pictures, I don't know, numbers, just some sort of data. Okay. And just like in math, where you have like y equals to mx plus b, where x is the input, right? It's going to be like a function, basically, right? So x is going to be the input, and y will be kind of our output. Got it? Right? And so we use code to take this input and get out and solve a problem using the output. That's kind of the very basics of programming. Okay? Let's see. So specifically in Java, right, input is going to be through multiple kind of ways, right? And it's going to get really complicated real quick, so we're not going to talk about input today. But for the people who are like eager to learn, I guess, you can use scanner. That's like the most famous one. It's ridiculously slow, actually. Don't use scanner instead. Buffered reader. This is kind of like the typical favorite. I don't know, my handwriting's really bad. This is buffered reader. You can search it up if you want to learn something new. And I think one more, they call it fast reader. I didn't write it in the notes, but it was developed by, like his new username is Second Thread. He's pretty smart. But I guess the easier one is output, right? I think you heard like other people say it, but most people use what's called system STD out, standard output. Okay, and this is used through system.out.print. inside the parentheses, you'll have what you want, like stuff you want to output. Okay. Now, Nicole, the president, she recommended for you to download, help you download IDEs. I'll explain that later, but I don't think we'll do that today. But whatever. So this is kind of like the formula for output, right? So I'll tell you this, in Java, there's going to be a lot of things you're not going to understand, especially for a beginner. Okay. If you look over here, this has public class hello world. You guys don't know what a class is, you don't know what static void mean, but you'll eventually get there. Okay. Yeah. Not even like high schoolers know everything. But yeah, so this is kind of like the formula. Print has multiple different functions. This has print ln, which prints the stuff, but then adds a line after it. And then printf, which has special stuff, but we'll talk about that later. This is kind of an overview. This is a lot of information, okay? But it's just extra stuff maybe you don't know, but whatever. But back to the beginner stuff. Back to the beginner stuff. Okay, so output is going to be output in what we call a console. If you look in your notes, there's going to be like a picture of a black box. Okay? Okay, what's up, dude? Just like sit. Okay? It's going to be inside of like a black box, and that's going to be called the console. If you've ever done like command line, if you want to download like an illegal game or something like that, that's also a console. Okay? It just like, you see a black box, how it goes. I already talked about that. Okay. So code is processed through what we call it as a compiler. Okay. It's kind of like a translator. It converts what the code is to machine code, and when you see machine code, it's going to be usually in like binary. Okay. Binary is we count in a base 10 system, right? So every time the first index goes to 10, we add 1 to the next digit, the following. In binary, we count by 2s, right? So after this, if you add 1 to the end of here, actually this is a bad example. If we add 1 to the end of here, it's going to be like this. If you don't understand, it's fine. I'm kind of getting through like an overview of everything. But yeah, so basically the main idea of this is the compiler takes your code and makes it so that it changes it to machine code so the machine can do and solve your problem. Okay. So now we're going to get into some basic terminology. So first things first is an IDE. This stands for Integrated Development Environment. Okay. This is going to be where you're going to be coding. This is going to be basically where you're going to be living in code and programming. Okay. There's some famous examples like VS Code, JetBrains, IntelliJ. So in your upper level CS classes, you're going to be using IntelliJ. Eclipse is a very good one. I recommend Eclipse. I don't know if I spelled that right, but I recommend Eclipse. And I think there's one more. Oh, there's online IDEs. So IDEs you can use online. Yeah, like Replit. You're going to be using this in your upper level high school classes as well. And an IDE basically, it's like the environment in which you can code. If you look on your notes, there's kind of above the console, above the black box, there's kind of a little snippet of code, and that's going to be where your IDE is. Okay, that's going to be, it includes your compiler, it includes all the things that are required to change into code, or change code into an output. So I recommend downloading Java at home, but I know that's going to be a really pain in the butt process. So if you need help, you can probably DM me. But yeah, I sent a YouTube video on how to download Eclipse, and then you also have to download Java first. Make sure y'all download Java and then use Eclipse. Okay. So now we're gonna get into errors. So I'm not sure if you've seen any jokes about programming, but basically 95% of what you're gonna be doing in programming in general is gonna be your errors. It's gonna be what's wrong with your code. And there are kind of 3 main types. We got syntax, It's when you, with code, you have to spell everything very specifically, and you have to write your functions very specifically, right? You'll notice when I like write my system.out, right? I have a semicolon at the end. That's important. If you don't have your semicolon, your code's not working. Okay, syntax. This is gonna be like English syntax. It has to be in a certain order or else it's wrong. Logic. So basically, logic errors is like your code works and it goes through the compiler, but it doesn't output the correct output. So let's say you wanted to output 2, but it outputs 3. That's a logic error. Runtime. So I needed to actually go back to the compiler. So the code processes, or your code is going to be processed through kind of like 3 different levels. The compiler, then it goes through runtime, and it goes through output. Okay? So the compiler makes sure it doesn't have any syntax errors. Okay? And then in runtime, it actually runs the code, and then it finally outputs it. Okay? But there are some errors that can happen in runtime, even though the compiler is checked it and it's good. Okay? Some errors include like memory, like out of bounds errors. I'm sure like some of y'all know what that is. But that's runtime. Okay? So also, especially within competitions, runtime is the most like pain in the butt like errors. You're gonna get like a couple of these, and if you see them, it's gonna be very hard to debug. Debug meaning like to fix your code. It's gonna be very hard. So now we're looking at like actual structure of code. This eraser is terrible. Oh my god, this eraser sucks. Okay. So first thing I want to talk about is I'm gonna write out an example. It's gonna be in the notes. Public class universe. Now, you're not expected to know everything in this thing. In fact, it's going to be like, some of this stuff I'm not even that confident in. But you don't need to know everything. Just know, like, kind of it's there and you have to type it. And then I won't type in the system that I've written. So everything in Java has to be written in class. Okay? Java is what's known as an object-oriented programming language. Basically, everything runs under a class. So when you're writing a code, just you have to put public class, and then your class name, and then into 2 brackets. And make sure they're brackets, not parentheses. Remember, everything has to be in like a certain way. Okay. Then you see a public static void main in this garbage, right? It's actually not garbage, it's pretty important. It's over there too, we'll see. But this is when your code runs, this is the only part the code looks at. You can add other functions, right? Y'all don't know what functions are, but it's okay. But in Java, the compiler only like kind of reads it, or the code is only run through public static void main. Okay, this is going to be the main function. That's why it's called main. Most important. Okay. But yeah, when you're like, let's say you're coding at home, make sure you write a class, and make sure you write public static void main, and write whatever code you want in here. Okay. Okay. So now we're going to explain organization. So code is organized through curly braces. You may have seen it earlier. Or see those curly braces? Blah, 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 blah. Okay. Code is organized through curly braces. So they're kind of in blocks of code. So in the first example, this is a block of code. Okay. Just like imagine like a bunch of code inside. Okay. This is one block of code. Now, what we can do is what we call nested blocks, right? Code block. We're going to call this B. We're going to call this A. Okay. So these two braces go together, and these two braces go together. You guys see that? Okay. So you'll notice that code block B is inside code block A. When code is inside like a larger set of braces, that's what we call nested. Okay. A lot of people actually get really confused, especially in comp sci A and data structures even. But if you see like inner parts of curly braces, that's what's called nested. Okay. It could be nested loops, nested if statements, blah blah. Okay. Whenever you see a set of blocks inside one another, it's going to be called nested. Okay. Now, if you separate within two different parts, notice how block A or block B is not in block A like in the first example. These are two completely different blocks. Okay, understand? So these are two different blocks, meaning two different sets of code. So, yeah. Oh, yeah, I forgot to talk about this. But if you've ever seen like a .txt file, right, that stores text. In Java, everything must be in .java. Okay, if it's not in .java, it's not going to run Java. Got it? Oh, here's some extra info. I didn't put this on notes. But Java runs through a thing called the JDK. This is the Java Development Kit. I'm not going to write it out. JVM, Java Virtual Machine, and I think there's one more. I think, no, maybe I used it. But this is kind of how Java like converts Java code into machine stuff. You're going to learn that at comp sci A. It doesn't matter at all. But they're going to like test you on vocab because it's an AP class. Okay. Let's see, move on. Okay. Cool. So now we're going to talk about comments. Okay, I'm going to write a lot of comments in my examples, right, in my notes. So comments are very important. So comments, there's two types. Actually, there's a lot of types in Java, but the two main types I'm going to use is this is an inline comment. Okay. And basically, this comment. Oh, by the way, comments in code mean that the compiler's not going to notice it, they're not going to care about it, they're not going to use it. Okay. Comments are just to help organize. They're going to help like say like, oh, this part code does this stuff, right? And it's going to tell you, it's going to be for organizational purposes, it's going to be for other people to read and understand your code. Okay, because code can get really ugly. So this is an inline comment, and this, the code or the compiler will not read only this line. But if I put in like stuff right here, the comment doesn't apply to this. Okay? It's an inline comment. It only applies to this line. Got it? Now we have multi-line. So multi-line starts with a front slash and a star. And then it can apply until it has the star and one slash. So I can write whatever I want in here. Remember, if I put it under here, the compiler is going to notice that, but it's not in the comment. Cool. Okay. So that's just comments. These are just going to be organizational. I'm going to put in my notes just for like to explain stuff, important stuff. But when you're writing code and like solving problems, using comments will help you organize everything and be very easy to use. Okay. So yeah, we'll go into variables. So variables in any sort of language are kind of like a container. They contain data. So the structure for Java is your variable type, your name, equal sign, and then whatever. So int stands for integer. Okay. There are multiple types. I'll go on because I think we have time. But int stands for integer. You'll notice I have a semicolon at the end. Very important. Okay. So imagine name being kind of like a box. Okay. And this stores the number 2. That's kind of how variables work. So if I had char the char stands for character. Maybe like A. This has its own box. Stores A. Now, I'll go into that next. But C is in its own separate box than name. Okay. Then, like separate. Now, one thing I would like to note is that, of course, you can't have you can't use too much memory. Your computer only has a set amount of I guess storage to store your variables, numbers, and all that stuff. It only has a set amount of stuff. So you can't have an infinite amount of integers. You can't have an infinite amount. Especially with contests, you may not need to know this at all, but int stores 8 bytes of data, or 8 bits or 8 bytes. Shoot, I actually don't know. Oh wait, no, it's 1 byte and 8 bits. Wait. 8 bits, 1 byte. But you'll get to know this terminology later. This is just for fun facts. So we're gonna kind of. So variables are kind of like math, where inside math, you solve for x and all that stuff like that. Variables store kind of data. That's kind of the main idea of variables. So we'll do an exercise. Yeah. So it's gonna be on the notes too. Read that clear? What is this going to output? By the way, these are 2 integers. Integers are numbers. What do you got?
5.
Exactly. Right? So in Java, with integers, we can do multiplication using a star. Yeah. This will give us 6. Division. This will actually give us 0. I'll explain why later. Y. 1, and of course addition. So for integers and other numeric values, we can do simple arithmetic. I didn't write that in my notes. Whatever. Yeah. So yeah. But I'll go into this. This is a frequently tested topic. It's called floor, or especially in CSA, is integer division. So especially when coding, and in Java specifically, they don't have decimal points. Decimal points are its own kind of area. It's called double. Okay, there's actually floats as well. But integer division is a frequently tested topic, and people get it wrong. So in here, x is 2, right? And y is 3. And so 2 does not divide into 3, right? So what the computer does is it takes the floor of it, takes the lower bound, right? And so when in reality it's 2 over 3, it rounds down. Okay, when I say floor, it rounds down. It rounds down and it goes to 0. Got it? It's a frequently tested topic. I think your CSA teacher will explain it a lot better than me. But when you do division, just remember the number you get has to be rounded down. So here's an example. 5, 3. What are you going to get?
1.
1. Good. Because 5 over 3, or 5 is not perfectly divided into 3, but it does make one group of 3, and it rounds down. Does everyone get it? Okay. That's a frequently tested topic. A lot of people miss that, actually. Not surprisingly how easy it is. But okay, so one of the special things about variables, which make it really nice, is called assignment. So assignment is where you assign a variable to I guess, a number, a value, whatever you want, right? So this is the exercise 2. Actually, I don't need to write this in there. Okay, what do you think y will print out? If I print out y, what do you think you'll get? 2? Yeah, because what happens here